All right, so let's continue with part E. We have 4 times arc cosine x dx, and you can always pull out 4. Um, and unfortunately, we don't have a basic integration formula for integrating arc cosine x because it's not one of those elementary functions. Um, so, in other words, you don't have a direct formula to integrate that. But we can use the power of integration by parts. Let's go back to L.I.A.T.E and check if we can do something with it. As you see that we have an inverse trig function in the integrand, and there's nothing else. So you may think that, okay, where's the second function? Because we always need the second function or second expression coming along with another expression over there. So we have only arc cosine x. What we're going to do, in fact, is to put a hypothetical 1 next to next to arc cosine. Okay, let me just put that here. So that now I have a function 1 against arc cosine x. Arc cosine x is in this L.I.A.T.E formulation, it's inverse trig. And then the other one, the constant function 1, is the algebraic function. It's a polynomial, essentially, constant function. So what I'm going to do is, like, since inverse trig comes before algebraic, so I'm going to call the inverse trig function to be u to start with. Okay, so let's just do it right here. All right. So I'm going to call u to be arc cosine x, and then dv to be like 1 times dx, essentially. Okay. So we're going to take the derivative of arc cosine. You can check the derivative formula card to get minus 1 over radical 1 minus x squared dx. And here v is just x. Okay. So now that allows me to use integration by parts formula, which is u times v minus v times du. Here we go. So u times v, x times arc cosine x, minus v times du. You have another minus sign over there, so it's x over radical 1 minus x squared dx. Okay, we're almost done if we can integrate this integral. And this is something that we had a similar example for. Like we have 1 minus x squared in the bottom, and then you have x at the top. So this is a good u substitution problem. So let me just close the bracket here, and maybe I can do the u substitution here. Okay. So I'm going to call the bottom without the square root to be u. Okay. And I'm going to look at du. Okay, du equals minus 2x dx. This implies that x dx is negative 1/2 du. All right, but remember, this u is totally different from this u and this vdu here. So this is a separate discussion. Okay, so let me just keep writing in white here, and I'm going to convert this integral and write it in yellow, so you won't get confused, hopefully. And I should put also negative 1/2 out, so I should pull that out. Negative 1/2 du over radical u, du over radical u, but I'm going to write radical u as like u to the power of 1/2. And since it's reciprocal, so it's like u to the power of minus 1/2 du. Okay, let me also use this integral sign in yellow. All right, let's continue from here. X arc cosine x. Let's integrate this. Minus 1/2 u to the 1/2 divided by 1/2. All right, use 1/2 divided by 1/2 using the power rule for integration. Okay, I have this 1/2 canceling this 1/2 here. Okay. So essentially, I'm left with u to do 1/2 for u being 1 minus x squared. Okay, because that's the part of the u substitution. All right, let me just write everything in white right now. X arc cosine x minus a radical 1 minus x squared, because that's what u to the power of 1/2 means. And I have a generic integrating constant. I think that takes care of the integral of 4. Well, I think we forgot to put 4 in the calculations. So here we go. I'm going to put 4 right here. Starting from here, I should put 4. Okay, I'm sorry about that. I totally forgot about it. But constant is not a big deal because eventually we can multiply everything by 4. Okay, so let me put the 4 here, and then 4 and here, and I have a generic integrating constant at the end. Okay, I hope this didn't confuse you much because originally I pulled the 4 out. Okay, and if you did not pull it out, and then you would probably call dv to be like 4dx, and then 4 would be carried forward automatically all the way. All right. All right, that takes care of part E. Let me finish this video right now, and I'll do the part F in the next video. Bye.